everyone, my name is Gwen from Faraday Academy. I'm a software developer as well as a content creator on YouTube. In this crash course, I'm going to be showing you how to use Fast API from the very basics to some of the more advanced features. The technologies I will be using are Fast API, which I will run with Unicorn as a development server. I will be using SQL Alchemy to create the models for the database, and I will also be using its new asynchronous ORM. The database in this course will be Postgres. I'll be running that locally and using Post2Co as a client to interact with the database. Some of the Python libraries I will be using are Pydantic and Alembic. So Pydantic will handle data validation, and Fast API has a really nice built-in way of using Pydantic with its API endpoints. And Alembic I will be using for migrations and tracking migration history, and I will also be using those migration files to seed the database with some initial JSON data. I will be using Poetry as a package manager instead of pip, which gives me some extra features like a lock file and automatically adding my production and development dependencies to a TOML file that it creates for me. I'll be using Flake 8 for code linting and Black as an auto formatter. And finally, pre-commit, so I can set up Git hooks to make sure I am committing and pushing properly linted and formatted code. All of the code for this project is in this GitHub repo. The link is also in the description below. You can check out different branches to see the different stages of development as we go through this course. I really hope you enjoy this course. I put a lot of thought and effort into making this, so if you have any feedback, comments, questions, please leave them in the comment section on this video or join my Discord server and ask me over there. Next up, I want to briefly explain what Fast API is and why you may want to try it out for your next project. What is Fast API and why might you want to use it? Fast API is basically a modern Python framework for building APIs and web applications. It came out around the end of 2018, so it's just celebrating its 3rd year anniversary at the time of recording this video. Some of its notable features and benefits are its speed compared to other frameworks. Some of the speed benchmarks for web frameworks that people have done show it to be on par with other technologies known to be fast, like Golang and Node.js. In addition, it provides support for asynchronous behavior out of the box with Python's async and await syntax. In addition to the speed of the framework itself, many developers, including myself, like this framework because of the speed of development. In other words, the reduced time it takes to spin up new projects and build out features. This is due to several things, including an intuitive API from the framework, sensible defaults that it provides for you, and a lot of built-in features like data validation, serialization, automatic API documentation with both Swagger and Redoc, built-in type support, and other features like security and authentication, WebSockets, sessions, cookies. It's not just for APIs either, since it has built-in template support if you want to use it for building a full-stack application. The documentation for this project is also wonderful. It's well written, has user guides and plenty of examples, which cover everything from how to set up a project to using a database, modularizing your code, and testing. This framework is built on top of the Starlet micro framework, which is also a modern, fast, asynchronous Python framework. If I had to compare this to another popular framework, the development feels a lot like building a Flask application, but it also comes with a lot of well-documented and built-in ways of doing things similar to what you would experience when working in a Django application. I want to quickly demonstrate the functionality of this app It is basically an API, so there's going to be no UI, and we will just be interacting with it through these API docs. I guess this is technically a UI, but it's not a front-end user interface. These are the automatic documentation with OpenAPI that FastAPI generates for us. We're going to be creating all of these endpoints with CRUD operations, and we'll be able to interact with the API directly from the browser here. Make different kinds of requests. And get responses back. This is basically the creation of a learning management system. If you look at the README on the GitHub for this project, there's a lot more information about what it does and an overview of its features. It basically allows users to be assigned courses. Users can be either students or teachers. Teachers can then manage and see student progress in the courses. And then for courses, you have sections and content blocks. I will actually be building an actual UI for this later on my channel in Vue.js as well. So let's go ahead and get into building the app. First, I want to walk you through installing all of the prerequisites for this project. Of course, you need to have Python installed. Right now, I'm using Python version 3.9.6. One tool I recommend installing for managing Python versions is PyEnv. This tool is available for Mac or Linux, and there is a fork available for Windows as well. I will link those in the description below. It allows you to install multiple versions of Python and easily switch between them. Now that I've installed the new Python version 3.10, I can now do PyEnv versions. Now if I want to change my version, I can do PyEnv global. There are a couple other commands that would also change the version for the shell, for example. I can go ahead and do version 10. I have to do the exact version. It's 0b4. And now if I check my Python version, now I'm currently using 3.10, and I'm going to go ahead and change back to the 3.9 version that I was using. The next tool I recommend you install is Poetry. Now, Poetry is a package manager for Python that you can use instead of pip. It comes with a lot more features out of the box, and you won't have to go through the extra step of freezing dependencies because it automatically puts those dependencies inside of the Python standard pyproject.toml file. It also creates a lock file to lock in all of the versions from the dependencies that you install, as well as dependencies of those dependencies. The final prerequisite for this course is Postgres. You will need a local instance of Postgres running on your computer. For Mac users, the easiest way is to use the Postgres app. You can go to postgresapp.com and easily download it. You also have Homebrew available. For all major Linux distributions, Postgres will be installable through your package manager. And for Windows, there is an interactive installer available as well. Once you have those prerequisites installed, we can get started with the actual coding setup. The first thing I want to do before coding anything is just to check my Python version. is 3.9.6, which is what I want. So now I can go ahead and create a virtual environment. I could use Poetry's virtual environment, but I'm just going to use the built-in Python one here, venv. And then I'm going to put it in a folder also called venv inside my project, and that way I can always look at my installed packages if I want to. You can see I have this open in my code editor, VS Code, so I just have my virtual environment in there so far. Now, to use my virtual environment before I install any dependencies, I can just do source and then point to that virtual environment folder called venv I created, bin, and activate. And now you can see I'm inside my virtual environment, so I can safely install local dependencies here. Since I'm using Poetry as my dependency manager or my package manager, I'm going to have to initialize a Poetry project. Now, Poetry has a feature where I could spin up a whole starter directory structure, but for this tutorial, I'm just going to be building all the files and folders from scratch. But I still do have to initialize the Poetry project and create that pyproject.toml file. So I'm going to do poetry init for that. And it takes me through the command line guide and just asks me a couple questions. I'm just going to use all of the defaults. And then it asks me if I want to define my dependencies interactively, meaning interactively in the terminal right now, and I'm going to say no, because I'm going to install those on my own after. So now it shows me a preview, and I'm going to hit enter for yes. And now in my project, I can see it gave me this default pyproject.toml file with my Python version and the initial Poetry setup here. Now, pyproject.toml is a Python standard. It's not just for Poetry, so some other libraries that we're going to be using are going to be using this same file for their configuration as well. So to start this project, I need to add two packages. So first I'm going to do Poetry add uvicorn for our development server and fast API. And I'm just going to come to the documentation. Let me go ahead and turn this on dark mode. Go to the tutorial user guide, first steps, and this is basically the Hello World app. So I'm going to copy this code here, and in VS Code I'm going to create a file. I'll call it main.py. Basically, I need to import fast API. We need to create an instance of this main fast API class from the framework, which will be the basis of the whole API that we are building. And then I can define my routes here. So this will just return an object hello world. You can see it's an asynchronous function. We're not doing anything asynchronous yet, but we're going to use that functionality later. To run this, I'm going to go back to my terminal, and I'm going to use that uvicorn package that I installed. And I have to tell uvicorn what file I want to run, which will be main, and then what do I want to run inside of that file? That will be app. You can see I have main.py, and then I have app inside of that. I'm going to hit enter, and you can see that uvicorn is running on port 8000 by default. So I'm going to copy this in my browser, and I can see the response from my endpoint here. That's basically how easy it is to get started with Fast API. Just two packages and a couple lines of code. One thing I want to go ahead and show you is the automatic API documentation. So I'm at port 8000, and now I'm going to do /docs. And you can see it gives me the Swagger documentation out of the box. I didn't have to do any additional setup, and all of the routes, which is just one so far, is here. This is interactive documentation. So it gives me details about it, and then actually if I want to try it, I can press try it out, and then it gives me this execute button. Of course, it's just a GET request without any URL variables, so I'm just going to click execute. It shows me the response here. There's also an alternative form of documentation that's used in certain types of projects. It's called Redoc. So this is really zoomed in, so this isn't the format you might normally see. Let me zoom out a little bit. And you usually see this in 3 columns. A lot of APIs have this kind of documentation. I won't be using it in this tutorial, but some people do prefer this type of documentation over the Swagger style. So it's really convenient that Fast API provides both of them out of the box without any setup. I'm going to start with the user endpoints for the application and create just a quick in-memory database before I move to Postgres. So you can see how to use basic GET and POST requests, and also how data validation works in Fast API. So I'm going to add one more endpoint here. And I'm actually going to say that these are POST requests. To the user's endpoint. And I'm actually going to make these at the user's endpoint. So I have one GET and one POST. I'm going to call this GET user. And this function I'll call create user. Since I don't have my database set up yet, I'm going to just create a quick users list here. And in my users endpoint, for the GET request, I'm just going to return the users list. And then for POST, I want to create a user. So I need to define a variable here. This will be called user. And basically, my post body that I'm going to pass in when I post to /users, that will be in this variable user. And this is going to make more sense. And this will make more sense in a few minutes. I'm just going to leave it like that for now. Now, when I pass in user, I'm going to say users, which is that list above, and then dot append. And I will append the user that I've passed in. Now I'm going to check this really quick in the browser, but first I need to run my server. So last time we did unicorn and then file name and the name of our Fast API instance inside the file, which is app. And now I'm going to add the flag reload so that whenever I make changes in the Fast API code, then it will automatically reload the server, so I don't have to start and stop it every time I make changes. I'm going to run that. And now I can see in my docs that I have a GET and a POST request. If I try this out, then I get that empty list. And if I post a user, let's see what happens. I'm going to try it out. It's asking for user here, and it's just giving me this regular text field because it has no idea what kind of data I want in that field. And it's just giving me this regular text field here because it has no idea what kind of data I want in that field, since I have not defined a type, which we will do in a second. So I'm just going to put a couple characters here. I get the message hello world. I'll fix that in a second. And now that should be appended to our list. So I'm going to try to get my users, and you can see I have a user in the list, which is just a string with the name Bob. So my get and post requests are working. I'm going to fix this object really quick. I'm just going to return something like success. That's fine for now. If I just wanted a string of the username, for example, then this might be fine to append the username. But really, when I want to create a user in an application, it's going to be an object with many different fields. And I really want to check or validate that those fields exist and that I am passing in a proper user object to save in the database. So built-in way of doing validation and serialization in FastAPI is to use a library called Pydantic. And so what we're going to do is actually define a user class with all of the types for each field that we want to exist in our user objects, and then it will validate that we are passing in a correctly formatted user object. So let's see how that works. One thing that I almost forgot to do is install the Pydantic dependency. So I'm actually coming back later and doing this, but just to show you, you can do poetry add Pydantic, and now we're going to use it. First, I'm going to import the library called Pydantic, and then I'm going to import base model. And now I need to create a user class. I'll create class user, and this will inherit from the Pydantic base model. And now I can define the fields that I want to exist on my user. So for right now, I'll just define 2 fields for an example. Email, and I need to use a colon, and then I define the type string. And then let me define a different type of field. I'll just say is active, and this will be a Boolean. And this is basically what I'm going to be using as my user type right now. So when I pass in a user via a post request, I want to validate that it has these fields, right? So I'm going to say that this user object that I'm expecting needs to be of type user. And that's basically the syntax that I use to define that. And now, if this isn't type user, then FastAPI will automatically send an error response for us. Let's try this out in the browser. I'm going to refresh. Now, I shouldn't have any users here anymore because the app's already reloaded. And you can see the example of the body that it's expecting. I'll try it out. And now it gives me this JSON boilerplate I can use. So I need an email. I'm not validating that it's an email, but just a string for right now. But I'll go ahead and make this an email anyway. And then is active, I'll leave that as true, and I'll press execute. Let's see what the response is. Success, which is just the string that I'm returning for now. And then let me execute this again. And now you can see that I have an object in the list, which is the user that I just created. Now, if I don't pass in the correct fields, let's say I get rid of this required field. Now I'm just passing in email. I'll click execute, and it gives me a 400 level status code and then automatically returns details of what is missing. It says that the isActive field is required, but it is missing. And all I had to do to set up that data validation is to just define the type that it's expecting and say that user must be of the user type. Now, the variables defined here could be from the body, they could be from the URL. So later on, we're going to talk about how to differentiate between different types of variables that we'll use in our API functions. For right now, we can just leave it like this. Some other features of using these types come from the built-in typing module in Python. So I'm going to import typing and use optional here. And let me define one more field on my user. Let me just call this bio, and I'll say this is a string 2, but by default these fields are required, and as you saw, they'll throw a 400 error if they're not provided. But if I want bio to be optional, then I can just wrap it in optional and then use square brackets and pass in the type that I want. My server should automatically refresh. So let me go to my browser, refresh the browser. And now I'm going to get rid of bio here, execute. I got success, and if I fetch the users, then you can see it just saved with a null value for bio since it's optional. So I can enter the string or not, and if there's no string, it will just set it to null. Now, it's not just for data coming in via post request that I can define the type. I'm also going to be using the Pydantic type classes for my responses. So for right now, I'm going to define a response model, and I'm going to say that this is user. Now, this is going to throw an error, but I'm going to go ahead and show in the browser real quick. Let me refresh, and I'm going to create a user, just any user. I'll just leave what's there by default. Okay, now let me try to get, and it gives me a 500 error. In my terminal, it's saying that the value is not a valid dictionary. It's basically giving me a validation error, and that's because it's returning a list, but when I define my response model that I'm supposed to be returning from this endpoint, it says it's a dictionary, this user dictionary, but instead I'm returning a list. So what I have to do is actually tell it that it's a list of these dictionary objects. So I need to also import the list type, and then I can wrap user with list using square brackets again. And now it will properly return a list of my dictionary objects. This is a very basic example of how validation works with Fast API. Later on, we're also going to be using this with SQL Alchemy and real data from a Postgres database. Now that we've looked at resource endpoints, both getting and posting data to our endpoint, let's create an item endpoint on this resource to see how Fast API handles URL path parameters as well as query params. So I'm going to put at app.get and then /users and then /, and here I want the specific user ID in my RESTful API. So I'm going to put ID here. And now anything after users and a / in the route will be captured into an ID variable in my function. So let me create that function. And let me say get user this time. I'm going to have the index of the user in the users list act as an ID for right now. So I'm just going to pass in the index as the ID. So I just need to return the user at that index. So I'm going to say return users and then at index of ID. Of course, I don't have the ID variable available to me yet in the function. So I need to actually list it as a parameter here. And then I can also use Python's typing syntax again. So I can say the ID should be of type int. Let's look at this in the browser. I'm going to refresh here. And I have my third endpoint that I just created. So let me go ahead and create a user. I'm just going to use all of the defaults here for now. Execute, and then another user, execute. Okay, now let me get the list of users, and I have 2 test users. Now let me come down here to my get user by ID endpoint. I'm going to go to try it out, and now I need to have the user ID or the index of that user. So I can use the user at index 0 or 1. So I'm going to do 1. And it returns the second user. If I do 0 here, then I get the other user. And if I do something out of range of the indexes that I have so far, then I get a 500 error because I'm not handling errors in my API yet. So I'm going to get to error handling a little bit later. First, I want to show you how to give some help text for URL variables, and you can do the same thing for query parameters as well. So if you look at this right now, this is our parameter. It says ID needs to be an integer. It's in the path, so of course it's required because you can't hit this endpoint without providing that path variable. Basically, I need to import path from Fast API here. And now if I scroll down here, I have my type hint syntax, and then I'm going to use the same syntax that I use for default values. And here I'm going to use path that I just imported, call it, and then I basically need to pass in 2 things. The recommended way to write this per the Fast API docs is to use an ellipsis from Python to show that it's required. And now I'm going to add a description here and say the description of this variable is the ID of the user you want to retrieve. And now if I go to FastAPI, I can see and get here that it gives me the description text, and then I have the field where I can enter in the ID. Now with these path and query imports that you get from FastAPI, you can also do some level of data validation. So just really quick, I'm going to add another argument here. And since this is an integer, I'm just going to say that the minimum number has to be 2. So I'll say greater than equals 2. Now if I go here, I'm going to try it out. I'm going to try it with 1. And you can see the error I get is that the value has to be at least 2. You can do greater than or less than or greater than or equal to, and some basic validation. And it works similarly for query params as well. Let's say that I have this user is active Boolean, so I want to filter the active users. How I might do that in an API is get some kind of query object here, and I'm just going to go ahead and call this query parameter also is active. The type will be Boolean, and I need a comma at the end of my other one. And just for example, we're going to import query here. So I'm going to import query, and now I can call this, and here instead of the ellipsis I'm going to say none as the default. I can also put in a description here if I want, but instead I'm going to use some validation. I'm going to say max length. It's not really instead, because you can use as many of the named parameters as you want, but I'm going to say max length is 5. Not a really good example with a Boolean, because anyway you're just going to put true or false. But basically I'm expecting is active, which FastAPI will parse for me as type Boolean. And just for this case of this example, actually I'm going to make it a type string, because otherwise this max length wouldn't really work, because it would be only expecting a Boolean anyway. So I'm going to use type string for this, and I'm just going to turn this into a dictionary to return, which will be user, and then some kind of query parameter, which, since this is already string, I'm going to go ahead and change the name to Q, like it says in the docs. So I'll just use Q here, and I'm just going to return it via the API. Okay, and now let me refresh here. I have some kind of error. It was giving me a value error while I was writing that endpoint. Let me go ahead and clear that and try running it again. There we go. And now I have a field for Q, which is my query param, and for the path variable. So let me create users and create another user, and just go ahead and create another user. I have all 3 of my users saved in that list. And now I can try out this new endpoint. I'll just pick any user ID and then a query parameter. So Q will equal cat. Execute. Oh, I forgot about the validation in the path. I'll just go ahead and put 2 here. Or I guess it's not greater than or equal to, so I'd have to use 3. I don't want to reset this API by changing this value, so I'm going to add user number 4 just for this example. And now I should be able to make this greater than 2 by using the ID 3. Let me execute. And I do get my user for index 3 and query, which is the cat, the string I passed in. Now I do have it where it should only allow me to pass in 5 characters at most. So let me change this to kittens, and it automatically validates and says value must be no longer than 5 characters. I don't know if you can see that in the hover text, but you can see that little box that popped up. For the query field, it doesn't even let me execute the API request. It just gives me the error right away, so I can't even execute properly. So I would have to delete 2 characters, and now it lets me execute, and it's Kite. So one thing some people wonder is, how does FastAPI determine if it's a post body or if it's a path variable or a query param or something like that, because they're all just parameters defined inside of this API endpoint function. Basically, it matches up the path variable first. So since this is required for any type of API, this might be get, put, delete, or whatever you want on this item API. And you can even have multiple path variables in here. Well, these path variables have to match to a parameter. Every single path variable must be defined as a parameter. So it will match those first, and then after that, the rest of the variables will be assumed to be query params unless it's a post request or a put or a patch request. And then it will assume this to be a post body. If you had some kind of ID here, then you would just add it here. It doesn't matter the order, so you would just add your path variable here of type whichever, and it would work the same way. It would look for the path variables first, and then whatever variable you're using to define the body of the post request. Now, since we got into some of the ways you can define metadata in your endpoints, for example, this description, before I end this section, I want to quickly just add some metadata to our API that will show up in our API docs. Right now, it just has this default boilerplate for FastAPI. So I'm going to copy paste some of the fields available from the documentation and then customize them for our API. I'm going to call this FastAPI LMS, and then a description, LMS for managing students and courses. Version is fine. I'm not going to have the terms of service. License, I'll just keep it at MIT. And now let me refresh the project. And you can see it changed the name and has the correct version number, and then added the other fields here. There are also options you can pass in basically to define docs for each type of endpoint. You can look at the tagging API. Actually, I just noticed I have an extra curly brace there. So let me get rid of that. I'm not going to show this in this tutorial, but you can find it in the FastAPI documentation. in this create metadata for tags section. So you can just search for that. I'm going to actually turn this into a Git repo so I can save this initial setup. So I'm going to do git init. And it is giving me the warning to change from master. I'm just going to go ahead and do that. I'm going to change my default branch to main. And I'm going to actually create a named branch for this. I'm going to do git checkout-b and call this initial app setup. And I think I'm going to prepend this with 1 so it's easier to find. And now if I do git status, you can see it does have the files I want, but also I need to add a git ignore really quick to ignore PyCache, and I also don't want to commit my virtual environment. I have a couple options for git ignore. So GitHub has default ignore files that you can use. In a repo at github.com/github/gitignore. And you can actually go through all of these. There's one for Python and so many different things. They're pretty good, up to date, but what I usually do is go to gitignore.io and I just type in all of the things that I want to ignore. So I'm going to type in Python. Not all of the things I want to ignore, but all of the tools that I'm using, and it will automatically add the correct fields to an ignore file for me. And I usually enter every different operating system in case someone from a different operating system uses this. They don't have fast API in here yet. No. So I think that's good. And it creates this ignore file for me. So I'm just going to do Command A, which is Control A on Windows, and I can copy it. And now I'll create a new file, .git ignore, and I'll just paste all of that in here. Now let me check one more time in status, and I don't have PyCache or venv to be created now. So I'm going to go ahead and commit these. I'm going to do git add just to add all of those files, and now I'm going to do git commit -m, and I'm going to say first commit with initial API setup. Now I'm at my GitHub. I'm going to go ahead and add a new repository. I'm going to say, I'm going to do it under Faraday Academy, and I'm going to say this is fast API LMS. All right, it's available. It's private right now. I'm going to make it public before I launch this tutorial. I don't want any of these things right now because I'm going to push fresh code up here. So I'm going to create the repository, and now I have my URL. Now let me just copy it. If I go to my terminal, I'm going to do git remote add origin and then paste the URL. I can see that it added if I do git remote -v, and now I can push to that new repository I created on GitHub. So I'll do git push origin and then the branch name, and actually I'll set this as the upstream so I don't have to define origin and the branch name next time. And now I can click enter. I can refresh here, and I can see my initial app branch. I have no other branches pushed up yet. but I can see my code is here. Now that we have already built a basic API, I want to go ahead and restructure the endpoints into different files to clean up and also prepare for the additional logic that we will be adding later on. It's going to make it more intuitive to navigate around, as well as provide a more real-world example of how you might actually build an API. To get started, we don't want to keep our endpoints inside of our main.py file, but instead we are going to separate types of endpoints into files inside of a new folder that I'm going to create. So I'm going to call this API, and I'm going to make 3 files in here. First, I'll make users for all my users endpoints, and then I'm going to make sections.py and courses.py. Now to start with users, I'm going to remove these endpoints and put them in the users file. And now of course I'm getting warnings because I have no imports here. So the first thing I need to do is import fast API into this file, and then I need to set up what's called a router in fast API. This is similar to blueprints in Flask, so I'm going to set a router. I'm going to define it as fast API router, call that, and now instead of app here, all I have to do is say router. And all my endpoints are now set up. Of course, I have other variables that I need to import now. So I'm going to get those from my main.py. I'm going to take the rest of the user variables first. Go to users. I like to put my default Python imports first, and then my packages, and then I would put relative imports. Of course, I am missing the query and path here. I'm actually going to get rid of these. And I'm going to say ID is int. And for right now, I'll just get rid of those. So now this should work exactly as it did before in the main.py file. The only thing I have to do is, now that I have the router inside of this file, I have to let my main application know about the router. So I can do app.include router and then pass in each router that I'm going to use. So I have to import the router from API.users and I have to pass it into include router. And now if I go to my browser, all of my endpoints are still there. But when I'm using the router pattern, I don't just want one router, but I'm going to have a router inside of each of these files. Since I've already typed out all of these user endpoints, I'm going to just copy paste the endpoints into the other files. You can see the router is defined in the same way in these files. So if I go to my main.py file, I'm going to now need 3 routers. Of course, I can't have 3 imports all named the same thing. So instead of doing API.users, I think the easiest thing for me to do is just to import those 3 files. So users, courses, and sections. And then I can just do users.router, courses.router, and sections.router. Let me see if those endpoints now work in my API. And you can see I have all of these new endpoints added. Now, one thing you'll notice in Fast API, it forces you to write a separate function definition for each HTTP method. So here I have the courses endpoint. I actually have get and post, but I can't put these together in one function, as some frameworks let you do, or chain them somehow, but actually you need to explicitly define a separate function for every single HTTP method that you want to use on this endpoint. And that is just a specific design decision of the creator of this framework. If you want to know more about the design decisions behind this framework, then I'll link a podcast in the description below. Actually, as you can see here in these two files, there's something I need to fix really quickly. And I need to change this ID to be the correct syntax for Fast API. Now that I have my API and all my routes set up and my app structured how I want, I'm going to set up the database config in the next section. Now, before I do that, I am going to create a new branch. I'm going to do git checkout -b. I'll call it to API setup. And I can do git status. I need to add my new API directory. I'll just go ahead and do git add everything, git commit -m, and I'll say creating routers for API endpoints and adding courses and sections to API. And I will push this. And now in my repo, you can see it saw that I pushed a new branch, and now I have number 2 API setup. Now let's hook up the database. Fast API has some really good documentation about hooking up the app to different types of databases. You can see the SQL databases section for a reference on what we are about to do. Basically, all of the examples here are written in SQL Alchemy, which is also what we will use. So the first thing I want to do is install SQL Alchemy. And now I can set it up in my application. There's some initial config that I need to do first. And if you scroll down on this SQL page, you can come to the section with the initial configuration here. And I'm going to use this as a starting point. So I'm going to go ahead and copy this and then go over to my code. And I'll create a database folder. I'll just call it DB. And then inside of that, I'm going to create a file called dbsetup.py and paste everything I just copied. And there are a few changes I want to make here. So first of all, I'm going to get rid of, this is just a comment as a helpful connection string to show you what it's going to look like if you use Postgres. I already have my connection string created, so I'm going to copy it and paste it here. You can see I'm using PostgreSQL and psychopg2, which I actually have to install this library. This is my username at localhost, and then this is the name of my database, FastLMS. That's just the name I gave it. I'm going to come back to that in a second. Now for the create engine call, my SQL Alchemy database URL has to be passed in first. Now for these connection arguments, this check same thread is true. You can read about this in the documentation, but basically I don't need this because I'm using Postgres and not SQLite. One thing I'm going to add here is this option future equals true, and that actually allows me to use the new asynchronous API in the latest version of SQL Alchemy. So I need to put future equals true there, and I'm also going to put it here. So both in the session maker and in the create engine, I need to have that option set so that I can use that latest API. Now, one more thing I'm going to add to this file is a utility that I'm going to use later when I connect to my API. This just creates a database session by creating an instance of the session local class. So now I have to take care of two things to set up my database. First, I need to install this library, this psychopg2 library, to use with Postgres, and then I also have to make sure I create this database before I can start using it. So I'm going to come to my terminal, clear that, and I can do poetry add, and then I need to do that psychopg2 library, but actually I'm not going to use the regular one, but I'm going to be using this psychopg2 binary library, which is basically the same library except there are no other dependencies. It's much easier to install. So I'm going to copy that, come here, and install that. And then that will work the same way. So now I need to create the database. So I need to make sure my Postgres is running, which it is right now. And actually I have already created this database here, so I'm going to go ahead and leave it. If I didn't have this database created, then I could come in here to my pSQL and create it from the terminal. Or what you will probably want to do is use some kind of database client for Postgres. The one I use right now, this is Post2Co, but you can use any other client. I use dbeaver on my other computer, but any client will work just as well. And all you have to do is come down to this button, add database, and I just created a new database. You can call it fast LMS. I already have a fast LMS, so I just call that fast LMS2. And now I have a database and I can start interacting with it. But I'm going to delete that. And now I have my database. I've installed all my required packages. I have Postgres running. And I also have my database config already in my db setup.py file. So the next thing to do is to create my database models. So let me create a folder inside db here called models. Inside that, I'm going to go ahead and create a user model. And actually, I will have a few models inside each file here just for simplicity. And I'm going to also create a course.py model file. And basically what I want to do is, first of all, I'm going to need to import that base variable from that db setup file that I created, because I'm going to be using that in this file. And then I'm going to need to import some things from the SQL Alchemy library. I'm going to basically need column types. So I'll probably need the column definition itself. I'm going to need foreign key, integer. I'm just importing all of the ones I'm going to need, and then I'm going to be using them as I go in enum and also text. One more thing that I'm going to be using in a minute is a relationship. So SQL Alchemy has an API for me to define relationships between fields and tables. So I'm going to go ahead and import that. And now I can define a class of type user. And for right now, this is just going to inherit from base, which, if you remember in our setup file, I was just calling that declarative base function. And basically that is the base for all of my models. You can create a custom base, but I don't need to. So I'm just going to be using that for every model. And the first thing I want to define here is the table name before I define any of the columns. So I'm going to say table name, and this will equal users. Now, one thing to note, if you're used to some other frameworks like Django, then you might not be used to defining the ID, as the framework usually handles creating an ID as a primary key by default. But here I do need to define an ID and set it as the primary key. So I'm going to say that's type integer, and I'm just going to be using the regular IDs that are auto-generated by Postgres. So those will be integers, and I'm going to set this as the primary key, and then index equals true. A few other columns that I'm going to want are email and role, which will be an enum because there's a few choices for role, and you have to choose one of a list of choices. And then the only other things are a few relationships that I'm going to create. So let me go ahead and define the email as a column. And then for right now, I'm just going to say that's a string type. I can have a special email type later. And I'm going to say the email must be unique. Create an index, and nullable. It can not be nullable. So nullable must be false because I need to require a value for email. And then role will be an enum. So I'm going to set it as a type enum and pass in a class that I am about to create called role, and I accidentally said enums. So remember, I imported enum here. But for enum, actually it's a little special. So I have to import the built-in enum from Python here in order to create that enum class. And I'm just going to create it up here. So I'm going to call it class role, and I'm going to set it as enum.enum. So I know there's an enum here from SQL Alchemy, but the one I'm inheriting from is the built-in one for Python here. And then the only two options will be you can either be a teacher type as your role in this application, or you can be a student. And then I pass it in and wrap it in the enum field, pass it in as a column, and then that sets this role as an enum. So I will have to choose either 1 for teacher or 2 for student when I set that field. And the second class I want to define in here, actually it's the third class, but the second model class is a user profile. So I'm going to say class profile, and this will also inherit from base. I'll do a table name here, so table name, and this will be profiles. And I don't want to type out all of these columns, so I'm actually going to copy paste them. It's pretty much like defining the columns before. Here I'm setting strings for first and last name that can be max 50 characters, and I'm requiring them. And then bio, I set that to be nullable true, so it's optional, and it's a text field, so there's no set maximum character length. And then I have a boolean for is active, meaning is an active user, default to false. I probably could put that on the user class, but I'll just leave that on the profile for now. And now what I actually want to do is create a relationship between these two classes. User should be attached to a profile. So there's a couple things I have to do here. The first thing is I want a field for the user ID. That will be a column, which will be an integer. And then that foreign key class that I imported, I have to tell it what foreign key I'm pointing to. So I'm passing in a string that says users, because it will be from the users table .id. So it will be users.id, and that's what this field is pointing to. Now, a profile always has to be attached to a user. So I'm going to go ahead and explicitly say that's nullable equals false. And now I need to define the relationship between these two tables. And to do that, I need to create a field on each table that will allow me to do things like profile.user or user.profile, and I'll be able to use the SQL Alchemy ORM in that way. So let me define a field called owner, and I'll use that relationship I imported. I need to point it at the user class that I created above for that model. And I need to set a back populates named argument, and I'm going to say that's profile. That means from user, I can access the relationship via profile. So it'll be user.profile. Now I also need to define the relationship in user. So I'm going to call this profile equals relationship, and this will be that profile model. And then I need to set back populates to owner. It has to be the name of this field on profile. So I'm saying it back populates to the name of that field, and this one populates to the name of that field. And that will become more clear when we start actually writing queries. And one more thing I want to use here is a lot of times when you are defining these relationships, it will be a one-to-many relationship. So for example, let's say this was a to-do list class and this was an items class, like to-do items. So you would have one list, but many items attached to that list. And SQL Alchemy defaults to this one-to-many structure. But in this case, we're only ever going to have one profile attached to a user. So we want to tell SQL Alchemy this is a one-to-one relationship, not a one-to-many. So the only thing we have to do here is say use list equals false. And now SQL Alchemy will expect that there's only going to be one profile attached to this user. So that looks pretty good for our users. Now we are going to use these classes to automatically create migrations later on. So I'm going to go ahead and finish setting up all of the models from our database schema. And we have quite a few under courses that we want. But they are all pretty similar to what we already did, with one exception that I'm going to point out. So I'm going to copy paste and put them in here. Now here are all the model classes from our schema, and actually there are two differences that I'll point out. So this URL type and then this timestamp mixin that I haven't created yet. Let me also fix this DB because the file's name is db_setup, and that needs to import base to inherit from the same as our user and profile classes did. Now, I'm going to touch on this first. So SQL Alchemy utils and this URL type. So this is actually a library that allows me to define a lot of special types and do some other things to kind of extend SQL Alchemy functionality. So if I look here, instead of one of these default types like string and integer that are provided directly from SQL Alchemy, I have this URL field on content block, and I want to ensure that it's a properly formatted URL. So instead of doing custom validation on this every time, I can simply use this URL type from this SQL Alchemy utils library. So let me look this up in the browser. And if you look at installation here, you can see you can just install it from SQL Alchemy-utils. And then there are a whole bunch of different features provided by this library. Let me go ahead and look up the URL type that we're using. Under data types, and you can see all of the different data types. It has email and all of these other things that we can import. So I'm going to go ahead and do poetry add SQL Alchemy utils. And now you can see it's no longer throwing an error. So all I have to do is import URL type or email or any types that I want, and then define them as you see here. So what's this mixin? So you can tell from the .mixin in the import path that this is a local file. So generally when you're creating models, there are a lot of models that you're going to want timestamps on. You're going to want to know the time that each row was created and then probably when it was updated as well. You might want other fields such as who updated it or some other type of metadata associated with the update. But I just wanted to create a simple mixin to show you how it works with SQL Alchemy. So I'm going to go in my models folder, create a new file, and say mixins.py. And I'm going to paste in some code in this file as well. So here I'm importing the Python standard date time module. And then from SQL Alchemy, I'm defining this pretty much like I would a regular model class. I still need to define columns, and I have the types for each column. Now, the difference here is that I'm not extending from base. Instead, I am wrapping this in this declarative mixin decorator. And basically what this does is allow me to create a class with fields here and then extend from this class into my other classes. So I can use inheritance and then basically have these created at and updated at fields in any other model class that I want. Now you can see with created at and updated at here that I'm setting defaults. So every time a new row is added to the database, it's going to already have the default time when it's added. In this file, the courses file, I have mixins import that timestamp, and you can see I'm extending from timestamp first and then from base in these different classes. So far, actually, I'm only doing it in the course class, but I also actually want it in the rest of these classes. So I'm going to go ahead and select all of those. And I think that's all of them. Yeah. So now they're all inheriting from timestamp. So I'm going to have timestamps on all of the classes in that file. I actually also want to do this for my user classes. So I'm going to know when users are created or updated. So I'm going to go ahead and import that. and then do timestamp and timestamp. And usually most tables in a database will have some kind of timestamp fields. So it's a really good mix in to have, and that way I don't have to define it on every single table. I can just inherit from it, and I might also have some other logic in here about how dates are added or updated. So this looks pretty good for my database models. There is a little bit more setup I need to do in my main.py file. So I'm going to have to import my database configuration into here and set up my models from each file. So I'm going to do from db.db setup, import session local, and also, actually I don't need session local here. Let me just import the engine right now. And now I need to actually import those files that I created my models in. So I'm going to import from db.models, import user, and my other one, course. And now what I can do is user.base.metadata.create all, and then I need to bind that database engine from my setup file, which is connected to my database via that connection string. So I'm going to do create all, and then I need to set bind equal to the engine that I created, and then course.base.metadata.create all, and then I also have to bind equals that engine. And that should be all that I need. Of course, I'm not using these typings in this file anymore, so I'm going to remove those. I'm not using these anymore. And then I'm not using the Pydantic base model because my API has moved to another place. So I'm going to do some cleanup there. And now I have my database models all set up and my database engine, and then also my routers for my API are all created. So let me make sure my server is still running properly. Let me go to my terminal and just run it real quick. Uvicorn, and it is running. If I go over here, I can go to Swagger, and it appears to be working. Of course, none of these endpoints are actually hooked up to the database. Before I do that, I do need to create my database tables, which is what I will use migrations for. So next, I'm going to be setting up and generating my migrations with Alembic. So now that I've created my database models, I want to use those models to actually create the tables with all of the right columns and data types in the database. Now I'm going to do that with a related library called Alembic, and actually this library is officially documented in the FAST API documentation as the recommended library to use for migrations. So I'm going to be using it for migrations and seeding in this project. The first thing I need to do is install it. So I'm going to do poetry add Alembic. And now that it is installed, I need to initialize it in my project. Now, so far, I have my API in the API folder and my database in here, and I'm going to create another folder called Alembic to put all of my migrations and some configuration inside of there. So what I'm going to do is say Alembic, and then use the init command, and then optionally I can set a folder instead of putting everything in the root directory. So I'm going to create a folder of the same name, Alembic, hit enter, and it gives me all of these logs. Basically, it created successfully. It generated some initial files for me, and then it's asking me to please edit the configuration connection settings in this alembic.ini file. It created this whole directory for me, which I'm going to look at in a second. And it also created this alembic.ini file in the root of my project. Now, the only thing I need to do in this file now, of course, I can look at different options like using an auto formatter on my migration files, but I'm not going to do that right now. I'm just going to come here to the SQL Alchemy URL variable, and I'm going to copy that out of my database setup where I also have this string. I'm going to copy the same thing and paste it there. That's all I need to do for the setup right now. Alembic knows where my database is, and it will be able to run migrations to create tables, update columns, etc. So in order to set up the tables in my database from all of the models that I already created, I need to create a migration file with Alembic. And I can actually do this automatically. The migration files will be housed in versions here. I'm going to do Alembic and then revision. I could create an empty revision, but instead I'm going to say auto generate. Now, before I run this command, one thing I did forget to do is to tell Alembic where to find my database models. So I'm actually going to do that really quick in this alembic/env.py file. And I have to update this target metadata variable here. And see how it gives some hints saying you can import models and then say mymodel.base.metadata. I think the easiest way to do this right now is to just import my DB setup, the base variable, and then just import my models inheriting from base. So I'm going to import user and course. And now what I need to do here is set target metadata equal to base.metadata. Now you could also use the base variable from each of these files and then set target metadata as an array or as a list of like user.base and course.base, or actually it would be user.base.metadata and course.base.metadata, but I've had an easier time just setting base.metadata and making sure I import my models because they also use that base variable. So it will be included when I just do the general base variable.metadata. I think that's all the config that I need for right now. So I'm going to go ahead and try running this command to auto-generate that migration. Okay, and it was saying all of the things that it auto-generated. And basically it created this auto-generated file for me. I did forget to name my file, but I think it's okay for the initial file. For this project, I'm just going to leave it. So here's my auto-generated file. Basically, it is creating my tables and all of the columns, any indexes, anything else that I had in those model files. Now, one thing about these generated files from Alembic is they're pretty good, but not perfect. So you definitely have to check everything that is generated and make sure it is correct. You'll notice it has the upgrade and also the downgrade functions. So it's going to create all these tables and set them up. And then also, if I want to undo everything that I did when I ran this migration, I have this downgrade file for that. So I'm going to look inside upgrade and see what I need to fix. There's a couple things here. So the first thing is that these SQL Alchemy utils need to be imported. So that's an easy fix. I can just come up here. Actually, I'll go to the database, go to this course file, and I'm going to copy the input that I have here. And actually, I just need to import this. I don't need that because it's just using SQL Alchemy utils, the default import. And that fixes that error. Now I'm going to try to run this and show you another error that I pretty much always run into when using enums. I'm going to clear this, and to run this migration, I could either point at the specific migration, or I can just run all of the migrations that need to be run. So I'm going to do that. I'm going to do Alembic upgrade head. And let me zoom out one so this is a little bit easier to see. So it's all on one line. Yeah. So Alembic upgrade head, and then I can run this command. And it tried to run that migration, but you can see there's a SQL error, create type role as enums. So there's a problem with my enums. And this took me a little while to figure out the first time I tried to do enums with Alembic migrations. Basically, the fix is that I had to remove the creation of enums from the table here because it's getting confused with the column name and the name of the enum. The fix is to just create the table first and then add the column with the enum after. So I'm going to paste in some code here. What this does is I'm using this add column method. I'm saying which table I want to add a column to. I'm defining column the same way here, and all of this information is the same as I was doing when I created the table. So now I can remove this, and I'm basically just creating the user table and then adding the enum column after the table is created. Now I have one more enum. If I scroll down, it's this table. So I have this type enum, and what I'm going to do is paste in that type enum and remove it from there. So let's see if this runs. I'm going to try to Alembic upgrade head again, and it did in fact run. Now I'm going to come in here to Fast LMS, double click, let me refresh, and now I can see all of those tables that were generated from my SQL Alchemy models. So if I go into users here, I can see I have created at, updated at. This is kind of small, but I have created at, updated at, ID, email, and role. It also created my relationships. So I have the user ID, and it's basically all set up now. I do want to show you downgrade real quick. So if I do Alembic downgrade base, I could downgrade to a specific migration file name if I wanted to, but base just removes everything basically. So I'm going to try this, and now it undid that whole migration that I ran. So I'm going to come back here to my SQL client and refresh, and now you can see all those tables are gone. The only one left is this Alembic version history, basically the migration table, which will have a field for the last migration run, which of course I undid the migration, the only migration, so now it just doesn't have anything in that field. Now I'm going to redo the migration, but first I actually want to add something. So at the beginning I mentioned I was going to seed the database, and that's something I do want to demonstrate here. So what I'm going to do is add a folder inside of Alembic. I'm going to call this just data, because Really, in my migrations, that's the only place I'm going to be using seed data. So I'll just leave it inside my Alembic folder. And I'll create a file. I'll call this students.json. I'm just going to add a few students into the database. So I'm going to paste that student data here. This is just some regular JSON data with a few users of type student, basically. And these are just my cat names, by the way. I don't really have 3 cats. These are previous cats. Fish is my only current cat. Now back in my migration file, I'm going to paste in some code here. This is just regular Python code, so not really in the scope of this tutorial, but I will show you what it's doing. First, this is code to seed the database with those student records. So basically, what I need to do is have a reference to this student table, or this user table actually, that I'm creating. So I'm going to call this users. And now I am missing some variables, so I need to import these standard library modules from Python, JSON, and OS. So I'm going to come to the top and do that. Now that I have those, I'm going to just really quick walk through. I am opening that file, reading the JSON data, and then inserting it as Python objects into the users table. Alembic gives me this OP module, and then I have this bulk insert function that I can use to insert data into the table. So let me run this migration now, and I should have some seeded data when I run it this time. So let me try to upgrade again. Alembic upgrade head, and it ran. So let me go back to my database client here. Everything looks good with the tables. Let me go into the users table, and I have 3 rows. All of those students were added as users into the application. I could seed a lot more data, and including the relationships in between data, but this is just for demonstration of the best way that I've found to seed data with Alembic. Now real quick, I want to show how to add another migration. So I'm going to change a column, let's say on my user table. Actually, this is perfect because isActive, I don't think that really belongs on a profile table. That's more of a user attribute. So I'm going to remove isActive from user, or remove it from profile actually, and put it in the user table. Alembic should make a migration that removes it from here and adds it to here. Let's see if that works. I'm going to try to auto-generate migrations again. Auto-generate. Let me try to name this migration this time. I'm going to say moving is active to user table. Hit enter, and now it did generate a migration file. Here is the generated string as well as the text I used to name the file. So let me go over. The file has a custom name here. So let me open this file and check out everything. Yeah, you can see the column is dropped from the profiles table, and that column is added to the users table. But in my database, it hasn't been changed yet. You can see there's no isActive here. It's still over in the profiles table here. So let's run the migration and see. Let me do Alembic upgrade head, and you can see it did just run that migration. So let me take a look at my database. If I refresh, isActive is now removed from the profile table, and it is now in the users table. Now it's unfortunate I already seeded this data in the table, so I would have to run a script or just come in here and manually update these to Booleans because that's a Boolean field. I'm just going to set these all to true real quick. Just manually save, and that's perfect. On that field, let me see what I have there. I do have nullable is true on that field for some reason, which if this was a real application, I would set that to nullable is false. Anyway, the default here is false, but for the data already in the database, it just set it to null. But any new data that I add, it's going to default to false in isActive until I switch it to true. So that's basically how Alembic migrations work. The Alembic documentation is quite good. It's at alembic.sqlalchemy.org, and there's lots of different things that you can do with Alembic. If you want to see the auto generation of migrations, it has a really good walkthrough at the Alembic documentation as well. Now we are almost ready to start actually building out our API endpoints and all of that functionality. We just need to make a few Pydantic models for data validation and serialization, and then we can get started with that. Now that we have planned our schema and implemented it in SQL Alchemy and used it for creating migrations to create the actual database tables with Alembic, there is one more time that we have to enter the fields relating to our models. And that is by creating Pydantic models, in other words, schemas. If you read the documentation for Fast API and scroll down in the SQL area to this section, Create Initial Pydantic Models or Schemas, then it basically recommends naming them schemas just to avoid conflicting with the SQL Alchemy models that we already have, because usually we would name them the same thing. If we have a user model in SQL Alchemy, we would also want to create a Pydantic model called user. And sometimes in Python, when you accidentally have two things with the same name, you can get confusing or hidden errors. So just make sure that you are not confusing your models or accidentally using the wrong model because they are named the same thing or similar names. Now I am going to pretty much copy what it has here and then update it. This is an example from the documentation, and you can see with users there are 3 different classes that extend from the base model for Pydantic. And to house these models or schemas, I'm actually going to create a new folder in my application. And just to be very explicit, I'm going to call this Pydantic schemas. And now I'm going to create that first file. So the user schema, user.py. I'm going to import that base model to inherit from the Pydantic library. And then I'm going to copy these. Let's look at this user base first. So the reason why it's separating these classes instead of just creating a single user class with Pydantic is that user creation and retrieving a user, reading a user, will involve different fields. For example, since the IDs in our database are auto-generated, when we create a user, we are not going to be expecting a user ID to be passed in. We just want the regular user fields, and then timestamps, ID, all of those fields will be auto-generated. But when we retrieve a user, we do want those fields like ID and timestamps. So let's go into our database and open up the user model. We can see we have email, role, is active, So we basically are going to want to set email and role when we create a user. So I'm just going to add role here, which will be an integer. Now for user create, we don't actually have a password field. If we were creating a user, we would want that field, but for this application, we don't have one. So I'm just going to leave that blank. And here, when I return a user, I want to return the ID, I want to return is active, and I'm also going to want those timestamps. So I have created at and updated at because of the mix-in here. So I'm going to need the date time here. And I'm going to do created at, and then updated at. I'm importing date time, and let me see, I should be able to do date time here. The final thing here is this config class, this child class. I'm setting ORM mode to true. This is very important if you are using an ORM in conjunction with Pydantic. Otherwise, you are going to have to manually loop over things to convert items returned from the ORM to Python dictionaries, and this just makes it work together much better. Before, in our API, we had this Pydantic model. We didn't have to set that ORM mode to true because we aren't using an ORM yet. But now that we are going to be plugging in SQL Alchemy, we need SQL Alchemy and Pydantic to work together. So that's why you need to set this to true. You can try it without true, and there will be errors that you will have to manually fix. So just make a note of this. If you're getting some errors, just check and make sure you've set this to true. Now that I have created my Pydantic schema, I'm ready to plug this all into the API. If you read the documentation, of course, it recommends putting the logic for interacting with the database in separate utility functions. So it creates this file, crud.py. The Fast API documentation does a really good job of saying why they do different things. So you can see why you might want to do that to make them reusable and to be able to test them more easily. Plus, when they get complicated, it's better to just abstract away that functionality from what's in your API into some utility or a service. These are basically the user functions that we might want. First, to get a user, this is the database query they create. Now this is with the old API. I don't want to call it the old API because it's not deprecated yet, but this is basically the SQL Alchemy 1.x whatever API that's synchronous using db.query. We're going to use this at first and then upgrade to their new asynchronous API. So I'm just going to take these and copy them. I don't have these items right now, so I'm just going to take all of the user functions, so at least we can get the user endpoints working first. And inside of my API, I'm going to create a folder called utils. I don't want to put all of these in the same file, so I'm going to create a user's utility. And then I'll create a utility for every other type of API. Now, I don't have a password here, so I'm going to get rid of that. But if you had a password, you could take care of hashing it and saving it here. Now, I am expecting role though. So I'm going to say role equals user.role. Of course, these come from two different places. User create And this user parameter is from Pydantic, from my schemas that I created. And then this user model is from the SQL Alchemy models that I created. So I need to import those because they're not in the same directory structure as the documentation example. So I'm going to go from my models. So I have models.user, and then I'll import user. And now from the Pydantic schemas.user, I can import that create user class or user create. And now I have to update this to be of type user create. And then all my models here, I think these are all the same. Yeah, so I can just delete those because I've imported the user model directly here. All of the logic is pretty straightforward. You can see I need a reference to my database session passed in, and then I need some kind of information that I'll use to query. If you've ever used an ORM before, this should be recognizable to you. You query the database, and this is saying I want to query the user table, and then I want to filter by this information, and I want the first record that you find, which we're only expecting to ever find one. Of course, we should only ever find one. Something would be terribly wrong if we had more than one user with the same ID. That's not going to happen because Postgres will create a unique ID for each user. But filter will by default return a list. So the reason why we're using first here is just to give us a single object. We just want a single object not being inside of a list. Now get user by email is pretty much the same thing, except we're filtering by email instead of the user ID. Get users is basically getting all of the users. We're not checking permissions or anything, so it's just going to return every user. And then if we want to, this has some pagination set up. So we can say we want to limit it to 10 users, or we want to skip the first 10 if we want the second page, etc. And then for create user, we are getting the validated data from Pydantic. So we are using that data when we use our SQL Alchemy model in order to create this new user. Then we have to add and commit it, and basically we're returning the created user, which should now include the ID and any other auto-generated fields, because those are created when we save them to the database. The last step in this process is to implement these utility functions in our API. I'll close out of all of these tabs. And now I have the users API. I'm not going to need this class anymore, or this in-browser database, because we have a real database. So I'm going to get rid of those. Of course, now I have to change things around a little bit. I don't need to import Pydantic anymore in this file. And I am going to import my utility functions though. So API utils .users, import all of them basically. So get user by email, and get users. Now you can see one problem I have created for myself already. Actually, I'm missing a function here. Oh yeah, I need to import create user as well. So let me just get that one real quick. Create user. And so now you can see I have made a problem for myself because I have get users here. I believe I have, another get user, and then I have create user. So I have naming conflicts here. So I need to have two different naming conventions. One for my API functions, which I think is less important than these functions, the utility functions, to be properly named. So I'm going to leave the utility functions alone and leave them with their name. There, now we can see them all. What I'm going to do, since I don't really care about the naming here, So I'm just going to put something else here like read users. I believe that's what it says in the documentation as well. And for create user, I'm just going to say create new user. Now in my APIs currently, they were just using that in-memory list, and now I want to use the actual database. So I'm actually going to paste in a few things here. I'm going to leave that line alone and just add a line that calls that get users function, which will just return all of the users in my database. But now I don't have any of these variables defined that I'm supposed to pass into the function here. So basically I need to define them as parameters in this function. What I'm going to do is optionally pass in skip, which defaults to 0 if nothing is passed in. I have the limit here of rows to return, which is at 100 if nothing else is passed in. And then I have my database session. Now, if you read the documentation for the database session and using it in your APIs, you can just read from this section, creating a dependency, and it kind of walks you through exactly what it's doing. We've already created this function here, actually, this getDB function, so we're going to import that in a second. But down here, somewhere, actually, let me just search for it. You can just read this section to understand what it's doing with creating getting the database session. This is a special function, this depends function that comes from Fast API that you can use in your endpoints, and then you don't have to manually pass in that database session. So I'm going to import that because I actually created that function over in my DB setup file so that I can just easily import it into any API file that I have. So I'm going to do it here. So from db.db setup import getDB. And of course I need session and depends. So that comes from SQL Alchemy. So I'm going to do from SQL Alchemy.orm import session, and then from Fast API, I'm going to import depends, and then I'm also going to need exception handling in a second. So I'm going to go ahead and import that and just put one space between my standard library modules and then my third-party modules and then my custom modules that I'm importing. The only things left that I need to do, well, I need to fix these two functions, but I also need this Pydantic schema, and I'm not going to have any naming conflicts here because all of my utilities, I'm just importing these. These are the ones that are interacting with the database, so I don't need to import any SQL Alchemy models directly. I'm just going to be importing my Pydantic schemas. So let me go ahead and get those. So from Pydantic schemas.user, I'm going to import, I'm going to need the user create. Since I'm using these for validation, I need these both in my utils and in here. So I'm going to say user create and also user. So now my user type is correct. So this endpoint should be completely correct now. So let me just comment out these and try this out in the browser, in my Swagger. All right, it's not running. Now if I go back to my browser, refresh, that works. Now let me get users here. Try it out. I'm not going to worry about my pagination, execute. I do have an internal service error. Let's see the error. Right. So the reason why I am getting this error, it's saying that my user class doesn't have the property that it's looking for, student courses. Now, why is it looking for student courses? It's actually because if I look in my database here in course and go down to student course, I can see that I have this relationship back to the user. So it's looking for a field on the user called student courses. And of course, I don't have that. Not in here. It's in this file. So after I created my courses models, I never added student courses to the user model because this was the first model I created. So I'm just going to add these two fields real quick. This will add the student courses field that back populates to the student field over here on student course. And then I'll have student courses over on my user model that it's looking for. And then on completed content blocks, this is also looking for student content blocks field over on my user model, and it will find that now. And that will back populate to the student field. So from my user model, it's looking for a student field over here, and it finds it here. So now my relationships should be properly set up. Let me rerun that endpoint. I'm still getting an internal service error. So now it's a new error, and it's basically complaining about the type for the role field, which is an enum. So why is it complaining about a role type? We're not saving anything into the database in those endpoint or in our get users endpoint over here. We are just trying to read what's already in the database, which are our seeded student data. If we look at the student data now, there is a role here. However, I believe when we initially seeded it, there was not a role. So if I look in users here, there's no role. So I would have to add this field. So I'm just going to change this to student, and this one to student, and this one to student. Now if I save changes, there are no null values in here. So I shouldn't be getting that none type error from Python. So let me try this endpoint again. Okay, I'm still getting an internal service error. It's basically giving me the same error. Let me restart my server. Now I can go back to my API, execute, and I'm getting that error. Okay, so this is good. Now it's not saying I have a none type error, but it's saying it's not a valid integer. Okay, so it looks like we are going to have to set this as an actual enum type. I'm going to import the Python standard enum, import enum, and then we're going to try this. Okay, let's see if this works. So if I go down here, execute, and that worked fine. I get all of my users back. I thought maybe because it returns an integer that would work for validation, but I guess I have to actually set it as an enum. Everything else seems to work and validate just fine. So now we have our get users endpoint working, and we just need to make the rest of our endpoints over here. Now I'm going to come into the user model and start uncommenting these. Let's just start one at a time. First with creating a new user in this post request. Of course, I have a utility for doing this, which is this create user utility that returns the new user that's created. Since it is returning that new user here, I'm just going to add a line of code here, Or actually, I can get rid of this line and just put it in the return statement. So I'll use that create user function. I need to pass in the database. I'm going to add the session for that in a second. And then I'm also going to have to pass in the user that I'm going to create. And you can see that it is expecting the user, and basically I need 2 fields on that user in order to create it. That is the email and the role. And that's of course part of this user create function because it's inheriting from user base, so it's expecting the email and the role. Let me make that named user. Here, I need to use the same parameter and definition that I did before. I'm going to copy that, bring it down here. And that's basically all the functionality that I need to create a new user. Let me test that out. So here's my post request for creating a new user. And here are the fields that it's going to give me in the schema. I don't need these 2 fields because I have default set. It's just going to automatically enter the current date time. So I'm going to get rid of that. Is active, I'm not going to be passing that in. ID, of course, will be auto-generated. So really the only things that I need are email, which could be anything. It's not validating right now for a correct email, but I'll just put that there. And then role, which is number 2, which is a student. So let me try posting this. Execute. And I get a 400 error. It's saying 2 is not a valid enum instance. It's complaining about a couple other things about the ID, saying that is active is missing. And it's also complaining that created at and updated at are missing. Let's fix this error first. It's looking for an enum instance, and of course we are using an integer. So there's actually a couple mistakes I made here. We'll get to this in a second. But here in enum, I'm using an integer enum, but I didn't inherit from integer here. There are a few different ways to fix this. The easiest thing to do is just inherit from int enum, which will expect to type integer here. And then one thing I have to change is in my Pydantic schemas, I need to change this so I don't need type enum here, but instead it should now be integer, and I can get rid of this. So that should fix one problem. Let's see if that works. I'm going to execute the same command, and yes, now it's just saying I am missing some required fields. Now, why is it saying I am missing those fields? It is because, so the fields are located here, right? But in my user create, when I'm creating a user, those fields shouldn't exist. It should be just these 2 fields. So let's see why it's looking for these 4 fields. If I go to my API, I can see here. So I have type user, but this is looking for type user, which comes from here. And the type I really want to use is user create. So let me do user create. So my API will be expecting the post body to have the fields on user create now. But let's see, let me go to my browser. I'm actually going to refresh now. Actually, I don't need to because this is fine here. So I'm gonna click execute. And now you can see this was created. And if I go to my users table in my database, I'm going to refresh the users table and I can see I do have that user, test@example.com, and that created successfully. So now let me go to my third endpoint, which is just get a single user. This should be pretty straightforward, especially since I already have the get user function here. And this will be my database query just to select the user. So I'm going to come here and do get user. And then I need to pass in DB equals DB. I'm going to pass in user ID equals user ID, which I'm about to create. Now I'm calling it in the URL, I'm calling the variable ID. So I'm going to have to change that if I want to use user ID instead. So I'm going to say user underscore ID. And then I do need to have the DB variable defined. So I'm going to copy the same logic and paste it there. That should work. Let me refresh and see if that endpoint exists. Now I have this get users and user ID. Try it out. Let me go for user ID 5, the one we just created, execute. And I did get my user back. Now if I do 3, execute, I get a user. There's no user at 4 right now, so let me execute. And I just get null. It still gives me a 200 though, and I do want to throw an error, or let me implement some error handling in the API now. And I already imported this HTTP exception class, so I'm going to be using that. And just here, I'm going to move everything on this line and set it to a variable here. So I'm going to say, I'll just call it DB user, and then I have get user, and then DB user. Okay, and now I can check if the DB user doesn't exist and throw an error here. So I'm going to say if DB user is none, and then I will raise an exception. So I'll use HTTP exception that I imported. I am going to set the status code to 404 because it couldn't be found. And then I can write a message in detail. So I'm going to say user not found. So now if I try this API again, if I hit execute on this user that doesn't exist, it just says error not found. And it actually gives me a 404 response instead of a 200, acting like it's working properly. And I also want to do this really quick for this endpoint. Actually, no, for the creation endpoint. So here I also want to check. So I'm going to do the same thing here basically. I'm going to do DB user equals, and I'm just using DB user here because I already have other variables called users in this file, or called user. So now I have DB user, and actually that's not exactly what I want to do. Let me put this back here because what I want to do here is check if the user exists first, and then if the user doesn't exist, then create the user. So I would want to throw an error before I ever create the user if the user already exists. So to do that, actually, I'm going to use the get user by email function. So I'm going to get user by email, send DB, and email is this user.email. And now I can say if DB underscore user, because if there is already a user with that email, it means the user already exists. And now I will raise an HTTP exception. And I'll just do the regular status code 400. And then detail is email is already registered. I can test this out on the user create. So if I go to post users, try it out, do test at example.com. Role doesn't matter, I guess. So let me execute. And I do get that error response now. That is the basic way of error handling in Fast API. Basically, without error handling, if there is no validation error, which it gives you validation out of the box if you use the Pydantic type hints. So if it's not one of those errors, generally it just returns a regular 200. So for everything else, pretty much, I want to raise exceptions with the proper status codes. You can also set a status code. Actually, I forgot to put the response model here. So let me do that and also set a proper status code. Let's see, response model is user. And I also want a status code. Since this endpoint is creating a new user, I don't want a regular 200 response, but I do want a 201 response. So I'm going to do 201. And that response means that the user has been created. For get user, I'm going to have the same response. Let me test that out and see if it works. For get user, okay, still get a 404. Let me try to get a valid user. And I got a 200, that works. Now if I create a new user, let me do test 2, execute, and I do get a 201 response code for created. So all of these APIs are working fine. I also have utility functions for the APIs to query the database. And then I made the first Pydantic schemas to validate my data correctly. And now I basically need to finish creating the course API, so for courses and sections and all of those things, and hook those up, which will include making Pydantic schemas for each one of those, and then also building out the utility functions and updating the API to query the database properly. Let's get started with the course endpoints. The first couple of these are very similar to what we already created with the user's endpoints. So we're going to be using most of the same logic. Basically with the user's endpoints, we have these 3 so far, where we can get all the users, create a new user, or get a specific user. And we're going to be doing the same thing for courses. So I'm going to copy over that logic and then create a utility file, and then also a Pydantic schema to go along with it. So the first thing I'm going to do is copy this get all users into this get all courses function, read courses. And I'm not going to paginate for courses. I'm just going to leave it as simple as possible. Let me make this named though. Okay. And then of course I'm going to want to grab this for the database session here. And then I'm going to need to import that up here. So I'm going to take these 4 and paste those here. Of course, this is going to be different. This is going to be importing from course in a second. And then this, where I'm saying users here, I just want to basically replace that with course. And actually this is get courses, so this should actually have an S on it. So now that I have get courses, I do want to go ahead and create that utility function. So I'm going to create a new file here, and this will be courses.py in my utilities. And then I'll need a matching Pydantic schema, which will be course.py. Create that. So in my courses.py utilities, this is going to be pretty much the same as users with a few updates. So I'm going to go ahead and copy this file over and change a couple things. And I'm going to get rid of this. Okay, so I've got single user, get multiple users, and create user, and these are going to change into courses. So I'm going to start at the top of the file, and first from the database models, I need to import my course model. So that's going to be course, and this would be course. And then the Pydantic schema, I don't have it yet, but let me go ahead and import it. That's going to be course create. And then let me comment out this for 1 second, and let me get these get requests working. So I'm going to do DB query, and these queries will be on course. And then of course user ID here, that's going to have to change to course ID. And even the name of the function actually. So if I have, let me change those names. That's going to be get courses or get course. So there's nothing surprising in this logic here. It should be the same logic to get a course or a user. We're literally using the same queries. One thing that is different is just that I've simplified this and I'm not going to have any kind of pagination here. So I can just get rid of the offset and limit methods. And since this is pretty straightforward, I'm going to go ahead and add this back in and finish up this logic. So I have user create, which is going to change to course create. I have user here. This is going to change to course. And then of course there's different information that's going to be inside of course. Basically I'm going to need a couple different things. Let me go ahead and open up this model here. So for course I'm going to need a title, the optional description, and then I'm going to need the user ID. So I need those 3 fields. So let me go ahead and get rid of that. And actually this isn't correct. It has to be course, not user. So I'm going to have to do title, which is going to equal course.title. And the same thing for description equals course.description. Should be right. And then user ID. Now normally I would pull this off of a logged in user, but I am going to be passing the user ID in via the API here since I don't have authenticated users. So I'm just going to be passing it on course as well. So I'll do course.userid, and DB user is going to change to DB course. Let me fix this. So that looks good. Now I have to work on my Pydantic schema so this actually works, because this isn't hooked up to anything right now. So if I go over to Pydantic, I'm in courses here, and actually I'm going to paste in this code just so I don't have to type it all out again. And this is pretty much the same as the user Pydantic schemas. The only thing that's different here is the user ID, which is a foreign key to the user table. And then the description is optional as well. Everything else is exactly the same, so I'm going to close out of that. That is already ready to import, and I am importing it here. So let me make sure course create, yeah, it's called course create there. In the API also, I need to import, actually let me go back here. So course, import course and course create. And now I'm going to have to import that utility. So from, let's see, api.utils.courses, import, let's see, get course, get courses, and create course. So I have those three utilities, and I already have get courses here, which should return a list of courses. Let me actually see if that works. If I do get courses, try it out, execute, and it does return a course. This is just test data that I had in there previously off screen. Get courses works. Now let me hook up some of these other API endpoints. Let me go to create a course. And create course should be simple here. Actually, I'm just going to change the name of this function just to be consistent with my users file, because I called it create new user in that file. I'm not going to do much with this function. I'm just going to say create course, and let's see, db equals db. And then I'm going to have to pass in a course. So I'm going to have to validate that. And the course that I'm passing in will be of type course create. And then of course I need the database session. So I'm going to do that. And that should be everything I need for courses. Of course, I do want to set the response type here. And that should just be course. And the response here, the response type, is going to be a list of courses. Oops. And I'm not importing lists, so let me do that from typing import list. And that all looks good. And for get course by ID, I'm basically going to use the same thing that I used in the users API, which I'm going to check and see if the course exists in the first place. If it doesn't exist, raise an error. Otherwise, return the course. And I already have the code for this, so I'm just going to copy it and put it over in my course API, and then copy these parameters. And here, this was just kind of copy pasted from API planning. So I'm going to update all of those with the proper syntax for fast API, which would be in curly braces. And actually, to go along with what I did over on user, I'm going to go ahead and do course ID. So these three endpoints should be working. Let me see if they are. Let me first check if I can create a course. So let me go to post, try it out. Title, description, I'll just leave that alone. And then I need user ID. Oops. User ID, which I'll just put 1. Execute. And it worked. I was able to create a new course. Now if I get all the courses, try it out, I can execute, and I see the course I just made as well as the other course that was already there. Just real quick, I also want to check via the course ID. I know I have a course that exists of ID 2. That returns just fine. And then if I put one that doesn't exist, let's say 7, that returns 404 course not found. That's exactly how I want the API to behave. Now, the only other thing I'm going to do right now is create an endpoint to return all courses for a specific user. And that's going to show how to query based off the relationship, which isn't too much different really from anything that we have done so far. This is going to be an endpoint on users actually. So if I go here, this will be at router.get, and then let's say users slash user ID, and then this will be slash courses. So when a student is assigned to a course, it should show up from the list that's returned in this endpoint. So basically students will have a list of courses that they are taking associated with them. That list of courses will be returned. So let me start with the response model here then, which will be a list of courses. The same thing I'm returning from that other API endpoint, which is here. Here, I'm returning a list of courses when I do a get to courses. But here, well, first let me define the function. So async def, let's say read user courses. Of course, I need to define user ID, which would be integer, and then I need DB session basically I just want to get a list of courses here, but I need a new method or a new function I'm going to create for this. So let's say get user, I'll call it get user courses. I haven't created it yet, but I'll say basically I need to pass in the user ID because it's based off of which user or the courses that belong to that user, and then I need to pass through the DB variable. And then all I'm going to do here is return that list of courses. So courses, and now I should be able to just create this function as a utility. So get user courses, since it's a list of courses, I'm going to put it in this courses file. And I'm going to say here, so def get user courses, and then this is going to accept DB, which is type session, and I'm going to need the user ID. That's all I need there. Oh, let me set the type of the user ID, which is int. And I don't actually need to pull the user. I'm just basically going to find the courses and return them. So I'm going to go ahead and put it in a variable, make a query. So db.query, and that will be on the course table. And I need to filter. So if I do filter, I can do course dot user ID, and that should be equal to the user ID that I'm passing in. So oops, that should be that. I want to get all of those. And now I'll just return courses. Let me see if this works. And actually, just to order this a little bit more intuitively, let me actually take that function and go up here. And I think I can, let me undo that. There we go. Okay, so get courses and then get user courses. And the only difference really between this query and this one is that I'm doing the filter by the user ID. So let's see if this works. So I might have missed something in all of those updates. Let me go back here. I should see my new endpoint. It's not starting. Let me check my server. So let me run my server. And it says course is not defined. Response model list course is not defined. So let me go into my API, and I should be getting that from Pydantic, but here, yes, it's true, it's not defined. So I need to import that. Actually, I'm going to import it here. So from Pydantic schemas.course, import, let's say course, and then from api.utils.courses import get user courses. Oops. Let's see if that works. My server's running, and now I have this new endpoint. So let me try it out. User ID, let's say 1. And I do get the courses associated with that user. If I do user 2, it's an empty list. So those are all the basic functions of FastAPI and querying, and you kind of see how you make API endpoints and then create utilities as functions for those endpoints to interact with the database. And then you kind of validate data with these Pydantic schemas that you create. I hope this has been helpful so far. I'm going to continue this by building out different features in some videos on my own channel, Faraday Academy. The only thing I'm going to do real quick in this video is show you a couple things that we can upgrade and clean up, including how you might implement asynchronous behavior and a couple items of code cleanup and making this repo a little bit nicer. Now I'm going to show you how to make FastAPI fully asynchronous by also using an asynchronous driver for the database and the asynchronous SQL Alchemy ORM. To do this, I'm just going to demonstrate it with one endpoint, and then you can kind of see how it works, and you'll be able to replicate that for any other endpoint as well. So I'm going to just change this read user endpoint, this endpoint where I'm making a GET request for a single user by passing in the user ID. To do this, I'm going to be using SQL Alchemy 1.4, which we actually already have installed in this project. We have version 1.4.28. Basically, anything before 1.4 won't support async. They added that support in 1.4, which also released a new API, and they call it 2.0 style because the 1.4 release is kind of the transitional release in between the older version of the API, which we've already been using with the .query method, and the new 2.0, which releases a few new top-level APIs that we're going to look at. Now, one thing that's important to note that I don't think is mentioned very often in tutorials about this subject, so I'm just going to point it out here. There are two different APIs just in general that you can use for SQL Alchemy, and I'm not talking about the old API versus the new one. It's actually using core versus the ORM. And you might get confused if you're looking at different tutorials and wondering why they look completely different. So I recommend you looking through this docs.sqlalchemy.org tutorial on there for version 1.4. And you'll be able to see, as you go through the tutorial, it'll point out kind of which syntax belongs to the core and which syntax belongs to the ORM, which is the one that I'll be using. This is kind of a matter of preference and also project requirements. The ORM is a bit easier to use in my opinion, but you can kind of look at both and see which one works for you. Right now, when we are interacting with the database, actually it's in here, we are using this db.query syntax and then passing in the table name. Now this is the 1.3 and prior version of the SQL Alchemy ORM. For the 1.4 version, which is the transitional 2.0, basically with the new API, instead of using the query method, there are some top-level functions that you will import and use, like the select statement. So basically, you import select, and then you use select.where or .filter by or order by or any number of different chained methods. I actually really like the new API. It reads a lot like a SQL statement. Of course, you can use raw SQL strings if you want to as well. That's also always available in the SQL Alchemy ORM. They also have other top-level methods such as delete, update. Let's see if I can find it here. So here's just an example of update and delete. So you would import update in the same way, pass in the model class that you have for that table, and then you can chain on where methods and any other methods just the same way. And it does point out the comparison between the older syntax, which is still valid, to use alongside the 2.0 syntax. So let me get started updating this endpoint to be asynchronous. Now the first thing I need to do is go into my database setup here, and basically every single variable that I create in this file needs to be changed a little bit to be async compatible. So this first line here, let me close that. It will remain mostly the same. I'll still be using Postgres, of course, and this doesn't really matter for async or non-async behavior. This is just the name of my database and then information regarding the connection. The only thing that really needs to change in my string is this driver. So I need to be using an async compatible driver. If you try to use async features with a non-async driver, you will get pretty good warnings in your terminal. There are drivers available for every major database. So if you're using SQLite, MySQL, Postgres, there are several different async drivers for each one. I'm going to be installing a Postgres driver here. So I'm going to stop my server and poetry add async pg. This is just a very fast asynchronous driver for Postgres. And now I'm going to run my server again. Now, I would normally just replace this URL with the asynchronous one, but since I'll only be using async for one endpoint right now, just to demonstrate this, I'm actually going to copy and make a complete duplicate with the new driver. And I'm just going to call this something else. So async SQL Alchemy database URL. And I also need to update the engine. So I'm not going to be using this function anymore for async, but there is another function that I import called create a sync engine, which will work for my asynchronous database connections. And there's actually an ORM extension from SQL Alchemy. So it's from sqlalchemy.ext.async.io. I can import create a sync engine. And now, again, because I'll be using both kind of, so I'm just going to create this side by side. So I'm going to call this async engine, I guess. And then create a sync engine. And I have to use my async SQL Alchemy database URL. And now I also have to change the session a little bit, although I can still use the same session maker function that I've imported. The only difference is that I have to let it know that it's an async function, so I can't use its default behavior. So what I'm going to do is copy this function, and now I'm going to actually remove everything inside of there. And as the first positional argument, I can actually pass in async engine and the class, which is going to be this async session class that I imported up here. and I'm going to set that as the class underscore named argument, and then I'm going to set expire on commit to false. Base equals declarative base. I'm going to leave that alone. And then this utility to get the database session, I'm going to, again, copy this. And I'm going to change this around a little bit. Basically, I'll just delete everything. The best way I've seen to handle these connections is actually with an async context manager. So I can't remember what I called that. Did I call it async session? No, I didn't rename this one actually. So let me call this, I guess, async session local. And then down here, I'm going to say async session local. I have to call that as, I'll just give it the same name here. Some people use the word session, or DB is what is used in the Fast API docs and some other docs, so I'll just use database here, DB. And here, similar to what I was doing before, I'm going to yield DB. Of course, I don't need to close anything because the context manager handles that for me. And inside of this context, I'm going to use await db.commit. And then here, because I'm using async and await inside my function, I have to make this an async function. And then it has the same name as my other function now. So again, I'm just going to change the name and prefix it with async for right now, just to differentiate it. So this is basically how you would set up SQL Alchemy for asynchronous database connections. If you look at different tutorials and the docs and even the examples in the docs, you'll see several different ways of doing this. This is just the way that I like to set it up, and I've found is kind of the easiest or most intuitive way that I've found. So after this database setup file, I'm all ready to use asynchronous sections or sessions. So now I basically need to update my API function here, and then also in my utility function for getUser, I need to update this to be asynchronous as well and use the new API. So for this, I'm just going to paste in the new API query and also a few new imports that I need. I need that async session import once again, and then from SQL Alchemy.future, I'm going to import the new select API, that top level API. Now I can replace this getUser function. It's going to be a little bit longer. Basically, I of course changed it to an asynchronous function, and then I'm using the async session. So of course I need to await that when I execute my query. I'm using the 1.4, the new 2.0 syntax for select from user, where user ID equals whatever user ID I pass in. So I build my select statement, save it in the query variable, and then I pass it to db.execute, which is asynchronous. So I await that, store it in result, and then there's this whole new API of methods. I can choose .1, .scalar, .scalars, scalar 1 or none. I'm not going to go too much into the API here, and I'm also not going to go too much into how all of this async stuff works. I just want to give you a little taste right now, and I'm going to be going more in depth in a video on my channel later on. That's basically all I need to do for this file. And then if I go into the user's API, I'm going to need to do the same thing. First, I'm going to code fold everything in this file. We'll just make it a little easier to read. And now this is the function that I am going to be turning into an async function. Well, actually it's already async, or the endpoint is, but I just need to make this use the new async function that I created. So basically I need to import a few things here. I need the async session here just for the type. I'm already importing the regular get DB function, but now I need to import that get async DB function to get the async session that I set up over here in DB setup with this function. So now I'm importing everything I need. And here, instead of session, all I have to do is async session, and then update this last variable. Let me close this sidebar here, and I'll say get async DB. And of course, get user is exactly the same function, except now I have made it an async function, so I will have to use await here. And those should be the only changes that I need to make right now. I need to run my server again. Oh, it says I can't import get async DB from db.db setup. Let me see what I did here. Oh, it's called async get DB. And here I'm trying to import the other one. So let me just change it here and try to run the server again. Interesting. It says get async DB is not defined. Oh, I didn't change it down here. All right. Yeah, in a real application, I wouldn't have two of these. Everything would just be all asynchronous. Oh, I am importing this twice though. I didn't realize that. There we go. All right, one more time. All right, now the application's running. And here, I'm going to try it out. Try to execute. And I get the same response body. So that means my API is working. Of course, this is a very small example, so you can't see the difference between using async or not async. And on top of that, there are so many more features and things you can do with asynchronous behavior and using the async IO, the need to run multiple async functions at the same time. I'm going to dive into all of that in a future video. But it is pretty nice in Fast API how easy it is to set up async endpoints with async database connections, and this new API from SQL Alchemy that supports that, and even just the intuitive nature of these new top-level functions I think is really awesome. There are a few more things that I want to do before closing this video that will only take a few minutes, and that is just a few code cleanup and maintenance items that will make this a little bit better. And that is to add poetry, black, and Git hooks. I actually meant Flake 8 black and Git hooks, but I'm going to be installing them with poetry. So poetry add Flake 8 black and pre-commit. And actually I meant to add these as development dependencies. So I might as well just show you how to remove dependencies. So I'm going to remove the ones I just installed. Okay, and now I will do poetry add and -d or --dev and add these dependencies. All right, I'm gonna go ahead and run my tab again. And now let me set up these dependencies really quickly in the project. You can see they're installed under dev dependencies here. And I'm going to add some more configuration directly to this TOML file. There are several different ways of setting these up and different options. I'm just going to show you kind of some simple settings. So if you look at the black documentation, there are some suggested settings and more recommendations here. You can also look at the Flake 8 documentation for some suggestions here. A few things that are important is lining up any rules of both libraries, or that overlap, I guess. Like the Flake 8 max line length should line up with the one you set for black. And basically, Flake 8, we're going to set it to automatically lint all of the code, and black will automatically go through and try to format the code in all of our files. And it actually does a really good job of that, better than any other auto formatter I have ever used. One more thing I'm going to add here is I'm going to paste in a file for that pre-commit library that I just installed. I have a .pre-commit-config, let's see, .yaml file. If you go to the pre-commit documentation, they have a lot of different options here. Basically, I am setting up black and Flake 8 to run on commits. So whenever I make a commit, before it will commit my code, it is going to run Flake 8 in black against my code. And I'm going to show you how that works. You can also do this or run it before you push code or in other situations, and you can manually run it as well. But I'm going to run it before commit here. So I can check. So I added pre-commit here, so I'll do git add that pre-commit file. And I can do git status again. And now I'll do git commit-am to add and commit all these modified files. Basically going to say adding Async DB connection, improving code quality with black and Flake 8. Actually, I forgot I made a mistake here. So you notice that the pre-commit hooks didn't run at all. And that is because I forgot to use the pre-commit install command. Now that I have that pre-commit YAML file, I can use pre-commit install to set up those Git hooks. Now they should work. So I'm going to do git reset, and then I'll just do head. So that basically undid my last commit. So now I have to restage and recommit everything. So I'm going to do my git add again. And I'm just going to copy the same commit that I had before. Now it's saying it's failing to find the interpreter for built-in Discover of Python spec. Let me real quick check Python version. So let me go back here. I believe because it's set to 3.7.9. Let me try setting it to my current version that I'm using in this virtual environment. So I can do git commit again. Okay, actually I made a mistake and I didn't mean to change this for Flake 8. I meant to change the Python version here. So let me change that. And okay, I'm going to commit this again. Okay, it worked this time. So these are the messages you should see if the commits worked properly. Now first with black, you can see that it reformatted these two files, so db setup and users.py. So this is just reformatting the files that changed here. And then it says it also reformatted API users. So this file, I think it changed this line, and basically you can see that if this line exceeds 80 characters, which I think it did, it moved this onto the next line and then the end parenthesis on the following line. And if it still exceeded 80 characters, you'll see that it will actually put each argument that you're passing in on its own line. So you can play around with the black auto formatter. It's really, really nice. So it says it failed because it had to reformat some lines. So that means that I'll have to commit these again, or not commit again because I guess the commit failed, so it didn't commit in the first place. But I'll run the commit again and this will pass next time because it already formatted those files. Now with Flake 8, this is not automatically changing or fixing these things, so I have to manually fix these linting errors. So first it's complaining about API/users that os.stat is imported but unused. I didn't even know I was importing that. All right. And then it's complaining in the same file that typing.optional is unused. All right. That should fix all of my errors. So now if I try to commit again, and you can see both black and Flake 8 passed. Now I can push this code. And that's live with all of my other branches. As I mentioned before, if you want to run this without having to actually commit, you can actually run pre-commit on its own. I'm going to actually copy paste in a command here. And you can see during a commit, it will run it against the files that you're committing. But now that I ran it manually, it runs it against all files. So you can see now it just reformatted all the other Python files, including this Alembic file, which I thought I was ignoring, but I guess I was not. Maybe I was ignoring it from Flake 8. Let's see. Oh yeah, I was just ignoring it or excluding it from Flake 8 linting, but I guess I'm running the black auto formatter against that, so I'll have to check if that still works. And now Flake 8 is complaining about courses.py and users.py in models, or course and user.py. It's saying that datetime is imported but unused. And then SQL expression null. All right, let me check those out. Let's see. Yeah, datetime is unused. I'm not sure why I was importing that, but that might have actually been an auto import, because if you accidentally type something, sometimes the code editor thinks you want to import it and it will automatically bring in the import up here. Anyway, let me commit this too. Let me actually check the Alembic versions here first, just to make sure I didn't break anything. Oh, nice. It just reformatted it here. All right, that's actually good because it was kind of hard to read before. So, okay. And then my second one looks good. All right, so I'm gonna commit this. Git commit -am linting and R formatting files. All right, that is a basic introduction to Fast API and all of the related libraries to be able to use database connections and asynchronous behavior, as well as just maintaining good coding standards with Flake8 and Black, and then setting those to automatically run. I'll also update the README with some of these instructions. Again, if you want to look at the code repo, it's the one that we created here. So it's at Faraday Academy /FastAPI-LMS. And you'll be able to see all of those branches for each step of the tutorial in the video. Of course, these branches were committed after each step. So if you want to look, or if you want to start in the third step, for example, and code it yourself, you'll have to go to this second step, 2-API-setup, and then you can add all the code for 3. I would love to hear your feedback on this tutorial. If you have any suggestions or anything you think I could improve, please reach out to me here or on Twitter or in my Discord. I will be going into deeper dives into many of these subjects in the future. I tried to keep it as simple as possible and explain enough to get all the basic parts in this tutorial, so I really hope that it was useful for you. If you want a deeper dive into Fast API and asynchronous behavior, I'm putting together some videos and articles on my YouTube channel, Faraday Academy, and also over on my blog, gwenfaraday.com. I hope you have a great rest of the year whenever you're watching this. Thanks again, and I'll see you in the next video.